If you are ever asked to solve an equation, that means you're looking for all possible solutions. So all values that make the equation true. To solve a linear equation, you can simplify each side separately and then get the variable terms on one side and the constant terms on the other, and then divide both sides by that coefficient to solve. That's not the only strategy to solve a linear equation, but it will work every time. From here, to simplify each side, I'm going to combine the like terms. So I have negative 2x plus 7 equals x minus 4. To get the variable terms on the same side, I'm going to add 2x to both sides. When I add 2x to the left side, I'm left with just positive 7 equals, when I add it to the right, the only thing it gets combined with is the x. So I'm left with 1x plus 2x is 3x minus 4. Since the variables are on the right hand side, I'm going to move the constant to the left hand side. So I'm going to add 4 to both sides. From here to solve, I'm just going to divide both sides by 3. So x is equal to 11 over 3. This is my only solution, so this type of equation is called conditional. To solve part B, I'm going to start by distributing the 3. At this point, you can notice that the entire left-hand side and right-hand side are equivalent. So no matter what value you substitute in for x, it will result in a true statement. So every real number should work. So every real number from negative infinity to positive infinity. This is called an identity. If you were to graph this on the same plane as this, you would notice that the two lines would be overlapping everywhere. To solve part C, I'm going to distribute the 2 first. To get the variable terms on the same side, I'm going to subtract 4x. But when I subtract 4x on the left-hand side, I'm left with 0 minus 16, which is negative 16. And on the right-hand side, I'm left with 0, or 0x. 0 times anything will just be 0. 0 minus 6 is negative 6. This is a false statement. This is never true. So there is no real solution to this problem. This is called a contradiction. If you are left with an always true statement, you'll have all real numbers for your solution. If you're left with an always false statement, you will have no solution. To solve a rational equation, you have two different options. You can multiply both sides by the common denominator, or you can get a common denominator all the way through. So there are many different strategies to solve rational equations. If you were to add x over 3 plus x over 4, your common denominator would be 12. So you could multiply both sides of this equation by 12. That will be a property of equality. So it will keep the solution to the equation the same. So it's not really changing anything. On the left-hand side, I'm going to distribute the 12. I'm left with 12 times x over 3. You can put this over 1 to make that multiplication easier, but you're left with 4 times that numerator. So we get 4x here, and then we'll see that the next value would be plus 3x, right? Because 12 divided by 4 is 3, using the same idea. Equals 24. You can combine your like terms on the left-hand side and divide both sides by 7. Here I simplify my numerators, so I distribute the 1, and I'm left with x plus 2 is equal to 3x minus 6 minus this entire quantity. Right, I'm subtracting a monomial, so these parentheses are not needed. But if this were a binomial, I would have to subtract that entire quantity. So I would want parentheses around it if this numerator were a binomial or a trinomial, something with multiple terms. Keep your common denominator. Using the same logic as the problem before, you can multiply both sides by x minus 2, x plus 1. If you do that, the x minus 2, x plus 1 will cancel out. That means that this equation that I write here is equivalent to the previous step for all values of x, except x plus 2 cannot equal 0 and x minus 2 cannot equal 0. Because this property of equality will hold true, right? You're allowed to multiply both sides by 12. You're allowed to multiply by negative 3. But you're not allowed to multiply both sides by 0. So that's where this comes into play. So x is not allowed to equal negative 2, and x is not allowed to equal positive 2. These are possible extraneous solutions. To finish solving my equation, I'm going to combine like terms on the right-hand side and solve this now linear equation. See if you can pause the video here and finish the problem. I got x equals negative 2 for my final answer. And as we saw a moment ago, that is not possible here, right? If I substitute this quantity into the original equation, I'll have an undefined value. So this is an example of an extraneous solution. Since that was my only solution, and I crossed it off, there is no other solution left to check, so my final answer would be no solution. I'm going to be solving quadratic equations very frequently in this class. I'm going to show you a few different strategies. We're going to solve by factoring first. When you solve by factoring, you want the entire quadratic equation to be set equal to 0. So I'm going to subtract 3 from both sides first. Once you subtract 3 from both sides, you're going to start factoring. To factor this, you want to create some quantity times another quantity to be equivalent to this. So you know that this number, this quantity times this quantity, would need to equal this quantity, because they're in descending order exponentially. So I could try something like 2x and x. I also know that this quantity times this quantity, since they would both be constants, would have to multiply to this. So I could try something like 2 and 2, right? Because they have to multiply to a positive 4. I think this would be a good guess, but not a great guess, because there's a GCF of 2 here, and there was no GCF of 2 in the original equation. So although this is set up in the way I want, this times this equals this, and this times this equals this, I wouldn't say it would be a great guess. So what could I switch? I could change using 2 and 2 for my two factors, and maybe I could try 4 and 1. But again, if I put a 4 here, that would imply there's a GCF of 2. So I can't put the 4 there. So I'm going to try a 1 here and a 4 here. It's still a good guess. 2x squared, positive 4. So this is a good guess. Now we have to see if our good guess is correct, and we check that by distributing. So on the side of my paper, I would do 2x squared plus 8x plus, now we distribute the 1, x plus 4, combine our like terms. If you get the same exact thing as the previous step, you have factored it correctly. Now that we know it's factored correctly, we can set each factor equal to 0 and solve because of the zero product property. The zero product property says that if you have some number times another number or the same number, and you know that it equals 0, you can assume that either the first number or the second number or both are 0. So that's why you can set the first factor equal to 0 and solve, and you can set the second factor equal to 0 and solve. If you only have a few solutions to your equation, you can write it in roster form. Remember, we start that with curly braces. We have the order of the roster form in numerical order, so from least to greatest. If I just wrote one of these solutions, so if I just wrote x equals negative 4, I would not get full credit for this, because when you are asked to solve an equation, you have to find all values that make the equation true. So make sure you find all values when you're solving different types of equations. If you can pause the video here and solve part B by factoring. The first thing I always look for when I'm factoring is a GCF. So I set it equal to 0 and then try to figure out if there's a GCF, a greatest common factor. There is a value that goes evenly into both of these. Numerically speaking, it would be 3. In terms of the variables, x. I can divide both of these by 3x and not create any fractions. So I'm left with 3x times 2x minus 1. You can get these quantities by dividing. 6x squared divided by 3x would be 2x. Negative 3x divided by 3x would be negative 1. You're always welcome to check that you factored out a GCF correctly by distributing back in and making sure it matches the previous step. Now that we have it in factored form, we can set each factor equal to 0 and solve. Zero divided by 3 is just 0. Add 1 to both sides and then divide by 2. So we have two solutions for this equation here. If you ever notice that you're solving a quadratic equation and there's no b term, right? If the coefficient of the b term is 0, using the square root method will be very, very simple. So if you ever see a quantity squared and there's no variables outside of it, this method will work really well. Your first step is going to be to isolate the quantity squared, so to get it by itself. So notice how there's a 4 attached to this one by multiplication. So to isolate it, I'm going to divide both sides by 4. So I'm left with x squared equals 3. So my first step, which is isolating the quantity squared, is complete. Once you have isolated the quantity squared, you're going to take the square root of both sides. Technically, when you take the square root of both sides, you're raising both sides of the equation to the 1/2 power. If you ever raise both sides of an equation to a rational exponent that has a denominator that is even, your final solution could have the potential to be positive and negative. The exception would be if it was 0 or you're taking the square root of a negative value. So to solve this, you would get x is equal to plus or minus the square root of 3. You could also think of it like a puzzle. What number squared equals 3? That's why you get the positive and negative value, because positive times positive is positive, and negative times negative is positive. See if you can try the first step for part B, which is to isolate the quantity squared. This is attached by multiplication to the outside, so it's a factor of the numerator and a factor of the denominator. So it does not impact the x minus 2 squared. All right, once you have isolated the quantity squared, you're going to take the square root of both sides. So I'm left with x minus 2 on the left-hand side, right, because I took the square root of a quantity squared, an entire quantity squared. So that's why I'm left with x minus 2. On the right-hand side, I'm left with plus or minus. This is really the square root of 2/3. Using our exponent properties, we could take the square root of the numerator and the denominator, and we will need to rationalize this to get rid of the radical on the denominator. So we can multiply this by the square root of 3 over the square root of 3. Square root of 2 times the square root of 3 is the square root of 6. Square root of 3 squared is just 3. So I'm left with a 3 on the denominator. From here, I'm just going to add 2 to both sides to get my final answer. So x is equal to 2 plus or minus the square root of 6 over 3. This answer is fully simplified. Unfortunately, not every single quadratic equation can be solved by factoring or using the square root method, right? So if I can't solve this by factoring and there's a middle term, I'm going to need another strategy. So the last two strategies will work whenever you're asked to solve a quadratic equation, so it'll work 100% of the time. To solve an equation by completing the square, you are going to factor out the leading coefficient from the first two terms. So the leading coefficient here would be negative 3, and you're left with x squared plus 4x in parentheses. Now I'm going to leave a blank here. This blank, this value that I add here, will make this a perfect square trinomial because I'm trying to complete the square. The second blank I have on the outside is going to help me balance my equation. Then I'm going to bring down the rest of the equation, which is the plus 2 equals 0. To figure out what this quantity is, you can take half of this number and square it. 4 divided by 2, which is 2, squared would give you plus 4. So it comes from b, which is the new b value. This is your b that I'm referring to, not this. All right, so take this value, cut it in half, and square it, and you'll get this quantity here. If I asked you to factor that quadratic trinomial in parentheses, you would get x plus 2 times x plus 2, or in other words, x plus 2 squared. If you have found this value correctly, if you've completed the first 2 steps correctly, it should factor into a quantity squared. To figure out what goes here to balance your equation, you have to understand what you actually did to your equation when you wrote this plus 4 here. So you actually distribute these values here, in other words, multiply. Negative 3 times positive 4 is negative 12, and you do the opposite here. So we're actually going to add 12 to keep the equation balanced. This would be equivalent to subtracting 12 from both sides. Step is to factor that trinomial, so you leave your negative 3 out in front by multiplication. You factor your trinomial, and you combine your like terms. From here, you'll notice that you have a quantity squared with no other variables outside of that quantity. If that's the case, you can solve it using the square root method. So the rest of this problem is going to look similar to the problems we just tried. So we're going to isolate the quantity squared, and then we're going to solve for x. You're welcome to pause the video here and try it on your own. I'm going to subtract 14 from both sides first, and divide both sides by negative 3. I'm going to take the square root of both sides. Don't forget the plus or minus. I cannot have a fraction under a radical, so I need to rationalize this quantity here. So I'm going to multiply the numerator and denominator by square root of 3. When you're simplifying, make sure you check that the value underneath the radical can't be simplified any further, right? So if I think about this, it's 6 times 7. I don't know the square root of either of those values, and there's no perfect squares as factors to any of them. So this does not simplify it any further. Your last step is to just subtract 2 from both sides. So you'll get x equals negative 2 plus or minus the square root of 42 over 3. Notice how that negative 2 is not on an entire numerator. The only thing being divided by 3 here is the square root of 42. Try to pause the video here and complete the square for this equation. Then come back and check your answer. We're going to factor this trinomial. So we're left with a 1 out in front by multiplication, which we will not have to write. X minus 1 squared minus 7 equals 0. To solve this, I'm just going to isolate the quantity squared, so I'm going to add 7 to both sides. Take the square root. Nothing to rationalize here, and the square root of 7 does not simplify, so I'm just going to leave it. Now I'm going to add 1 to both sides. Another strategy that works 100% of the time is the quadratic formula. In order to use the quadratic formula, you need to make sure your quadratic equation is in this form. To do that, you can identify your a, which is the coefficient of x squared, your b, which is your coefficient of x, and c, which is your constant. So for the first example, I'm going to move everything to the left-hand side. I prefer it when my a value is positive, so I'm going to move everything to the left-hand side. I also prefer that a value to be positive when I'm solving by factoring. Once you have it in this form, identify your a, b, and c values. You can use the quadratic formula. When I use the quadratic formula, I do calculate a few simple steps in my head. This means the opposite of b. So the opposite of 3 would be negative 3. Plus or minus the square root of b squared. So what is 3 squared? Try to do that in your head. 9. Minus 4. See if you could do a times c in your head. 1 times negative 9. 1 times negative 9 is negative 9. B squared minus 4 times AC. Make sure you put that all over. So negative 3 should be on your numerator. 2 times A. So 2 times 1 would just be 2. If you do those simple pieces in your head, the quadratic formula will be much easier to solve with PEMDAS. Your next step is going to be to multiply these two quantities together. Becomes plus 36 all over 2. Your next step is to simplify inside the radical. I would be done at this step here, except the square root of 45 does simplify. So you always want to simplify your answer as much as possible. The numerator and denominator do not have any factors in common, so this is fully simplified. For part B, it is already in the form that you want, so you can identify your A, B, and C values right away. But since you're actually solving an equation, you can notice that there's a GCF here, and you could divide both sides by that GCF if it's a numerical GCF. So notice how 2 goes evenly into every single term. So I'm allowed to divide both sides of an equation by 2. When I do that, I'm left with 4x squared minus 12x plus 9 equals 0. The a value would now be 4, the b value would be negative 12, and the c value would be 9. These are much easier values to deal with. If you use the original a, b, and c values, you should get the same final answer once you fully simplify. So feel welcome to pause the video here and try to complete this problem using the quadratic formula. All right, we have the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Check your first step with mine, and then start simplifying. Multiply these first, and then work inside the radical. 144 minus 144 becomes 0. The value underneath the radical, so the b squared minus 4ac, this quantity is called the discriminant. If your discriminant simplifies to 0, you will have one real solution. If it simplifies to a positive value, you'll have two real solutions. Notice this example here. If this ended up being a negative 45, so if your discriminant was less than 0, you would have no real solution. To solve a polynomial equation so far, we can solve it by factoring. We'll learn other strategies as we go throughout the class, but as of right now, we're going to try to solve it by factoring. So your first step is going to be to set it equal to 0. Here I noticed a GCF, so I started by factoring out the GCF. Once I factored out the GCF, I wanted to make sure it was fully factored, which it was not, right? Because I can factor this quantity here. So bring down the monomial out in front by multiplication, and then we factor this binomial here. Once it's fully factored, we set each factor equal to 0 and solve. So we divide both sides by 3, which is 0, and then we take the square root of both sides, which is 0. So we get x equals 0 here, x equals 4, and x equals negative 4. I looked for a GCF on the next problem, but I did not see one. If there are ever 1, 2, 3, 4 terms and no GCF, what I want you to do is I want you to try to factor by grouping. So you look at the first two terms and you pull out their GCF. Then you look at the second two terms and you pull out a GCF such that what's left in the parentheses matches what was left in the parentheses before. So I like to double check by distributing. X to the third minus 3x squared minus 3x plus 9. If you can get it so that this quantity is equal to this quantity, you've rewritten the problem so you can factor out a GCF. So in this case, the actual GCF is going to be a binomial x minus 3, and you can multiply that by whatever is left over. So if you divide this whole term by x minus 3, you're just left with x squared. If you divide this entire term by x minus 3, the only thing left is negative 3. From here, I try to factor as much as possible. So x squared minus 3 does not factor any further. So I'm fully factored. Now I set each factor equal to 0 and solve. To solve an equation with a rational exponent, so we can see that this is a rational exponent in disguise, right? 2x plus 7 raised to the 1/2 power. I like to start these by isolating this quantity that is being square rooted or being raised to that rational exponent. So I would add x to both sides first here. To do this square root on the left-hand side, I'm going to square the left-hand side and square the right-hand side. The left-hand side is simple, but the right-hand side, a lot of students make a mistake on it because they forget to expand it out. So make sure to go from here to here. When you square a binomial or a trinomial, you have to expand it out because I don't want you to forget the middle term. From here, you're just left with a quadratic equation, and you've squared a square root, so you've gotten rid of a few domain restrictions, so you do want to make sure that you check your final answers. I'm going to set this equation equal to 0, and I'm going to move everything to the right-hand side because I want my leading coefficient to be positive. I solved the equation, and I got negative 3 and 1. Now I do have to make sure I check my final answers. To check your final answers, you need to check it by plugging back into the original equation and making sure it is true. The square root of 1 is 1. 1 plus 3, it's only positive 1. 1 plus 3 equals 4, and 4 does not equal 2. So that means that negative 3 is not actually a solution. That's an extraneous solution. So now I try 1. Substitute in 1 wherever you see an x in the original equation and solve. This is a true result, so the only solution is x equals 1 for this equation. If both of them didn't work, I would have to write no solution. The square root of a quantity is equal to that quantity raised to the 1/2 power. So to undo the square root, we squared both sides, and the exponent property is power to a power you multiply. So it becomes x to the positive 1. So that's how we got 2x plus 7 raised to the positive 1 power. So notice that if you raise both sides to the reciprocal power, you simplify.